Hello everyone, hopefully you are doing well. We'll continue with our lesson light. Coming to today's lesson, when you see into a mirror, you see your image. So image is a picture of the light source that light makes when anything bounces off that shiny surface. The mirror is a shiny surface, so the light source makes it the picture is made by the light source when light bounces off that shiny surface. Now light actually bounces off or reflects off a mirror the way that sound echoes off a cliff. Remember, the sound echoes in the same way light also strikes back. This is called reflection. The image in a mirror is clear because most of the light wave reflects the same way off the mirror's smooth surface. So reflection is the organized scattering of a wave, or in another way we call it the law of reflection. When light hits a mirror, it obeys the law of reflection. And the law of reflection says that at whatever angle the light strikes a surface, it bounces back at the same angle. This is what the law of reflection tells us. The angle of an incoming light ray equals the angle of the reflected light ray. So an image in a flat mirror appears to be behind the mirror. As you can see here, it appears to be behind the mirror. Now the distance to the image, distance to this image is equal to the distance that light traveled from the object to the mirror. So the image is formed back of the mirror, and law of reflection again is, it says that at whatever angle the light strikes a surface, it strikes back, it reflects back at the same angle. So curved mirrors can also be made with curved surfaces. We call them the concave and the concave mirrors. If they're curved in, we call them concave. As you can see here, they're curved inwards, okay, and if they curve out, they're called the convex mirrors. Curved mirrors can form many kind of images. They may be upright or upside down. The image can be upright down, or it can be upside down. They may also be enlarged or reduced. Concave mirrors always produce images that are upright and reduced. So there are a lot of uses of concave and convex mirrors. You can zoom in into or you can widen the angle with different views. Remember, we said that light can be bent, and an example I gave you in the yesterday's lesson also, that when you place an object in a glass of water, it appears to be bent. Yet if you pull the object out, it is still straight. So how is that possible? That is possible due to the bending of the light, but not the object. It is the light which bends, which when it enters from one medium to another medium, from the air to the liquid, it changes in speed. Okay, that's why we see it refracting, and this is called refraction. So refraction is the bending of waves as they pass from one substance into another substance. Although refraction is not noticeable with sound waves, but it is easily seen with light waves. So as we said that light rays can refract. Now when they enter a denser medium, they bend to make a bigger angle with the surface. But when the rays leave a denser medium, they bend in the opposite direction. Lenses use the refraction to shape images. Convex lenses work like the concave mirrors, as you can see here, curving the rays inwards like the concave mirrors did, as we studied. And on the other hand, the concave lenses, they work like the convex mirrors. They allow the rays to move outward. So convex lenses and the concave mirrors are the same idea. The rays, they are curved inward, while concave lens and convex mirrors share the same idea of rays are moved outward from the focus. Now, lenses are also used in different ways. For example, they're used in eyeglasses to make objects appear in focus. We may also use it in cameras or telescopes to change the size of the image we see. Now, the image's size and location depends on where the object and the lens are in relation to each other. That's all the lesson for today. Thank you very much. Please feel free to ask any question if you did not understand.